Hi, welcome to Barney Tech channel. Here we are going to see Transformer Vector Group Testing Part 2. In Part 2, we are going to see two types of Vector Group Testing. One is Dd0 Vector Group and another one is Dd6 Vector Group. First we will see Dd0 type Vector Group. Here we have to satisfy three conditions. Before doing our testing, we have to give supply for three phase RYB and we have to short R from HV and LV and we have to make the barricade. This is our vector group representation. This is our HV side representation. This is our LV side representation. This is our LV side denote the vector group 0. Now for making easy testing, I am going to merge this LV with HV. Just check this. I am making 0 vector group over here. That is 1U and 2U shorted. So our connection will be similar to this. Same thing I am going to draw over here. This 1U and 2U is shorted. 2W, 2V. Here 1W, 1V. In this we have to check three conditions. If these three conditions satisfy, then we can pass this vector group. First condition 1. We have to check the voltage over 1U and 2W. We have to check this voltage. That is 1U, 2W voltage we have to check. Second, we have to check this 1W, 2W voltage. Third, we have to check this overall. That is 1U, 1W. The voltage between 1U and 1W. 1U, 1W. When you see here, when you add these two, it should come here. So we have to add this two value. When you add this two value, it should be equal to this face to face voltage of HV side. That is your R phase and B phase voltage. For this condition, first we have to check R phase of your HV and B phase of your LV voltage. Second, we have to check B phase of your HV and B phase of your LV, and we have to add this 2 voltage. Finally, we have to check R phase of your HV and B phase of your HV. This face to face voltage we have to note, and we have to cross verify that this value is equal to when you add this previous measured value. For condition 2, we have to do same thing on other side. That is, we have to check 1U and 2V voltage. From here to here we have to check 1U and 2V, and we have to sum by here. That is 2V and 1V voltage. When you add this voltage, this should be equal to this overall. That is 1U, 1V. 1U, 1V. That is face to face voltage. It should be equal. We have to check R phase of your HV and Y phase of your LV voltage. We have to note this value. Next, Y phase of your LV and Y phase of your HV. We have to note this value. When you sum this value, it should be equal to R phase of your HV and Y phase of your HV. That is 1U, 1V. If this is satisfied, then condition 2 is okay. Now we can go for condition 3. We have to check this and this. We have to check this value. That is 2W, 1W value. The voltage between 2W and 1W. We have to check this value. And this value should be lesser than, it should be lesser than 1W, 2V. This is our condition 3. We have to measure this B phase HV and B phase LV voltage. This voltage should be lesser than B phase HV and Y phase LV. This should be greater than our previous measured value. If this is condition okay, if your all these three conditions get satisfied, then it satisfies the Dd0 vector group. Now we can see Dd6 vector group how to do this testing. Now we are going to see the vector group testing for Dd6. For this vector group, this is the vector group representation diagram. Here I have joined 1U and 2U. So I am going to join this 1U and 2U. Now 1U and 2U get shorted. Here this HV and LV winding is shorted. Similarly, this vector group 1U and 2U is now combined. So our vector group U is faced towards 6 and vector group 1 faced towards 0. Now we are going to check this for this three conditions. I am going to draw this same over here. This point is 1U, 2U, and this is 2V, this is 2W. This is 1W, this is 1V. For condition 1, I am going to check voltage between here and here. That is 1U, 2W. Second, I am going to check voltage between 1U and 1W. 1U and 1W. Third, I am going to check voltage from 2W and 1W. 2W, 1W. Now, if you add this two value, this should be equal to this over here. This one you can clearly see here. When you add this and this should be equal to this whole value. That's what we are going to see in this condition. Here we have to check R phase of your HV and B phase of your LV. You have to note the value, then you have to check the phase to phase, that is R phase of your HV and B phase of your HV. This, when you sum these two value, this should be equal to B phase of your HV and B phase of your LV. 2W, 1W value. If this is satisfied, then condition 1 gets satisfied. For condition 2, I'm going to do same thing towards here. That is, I'm going to check the voltage between 1U and 2V. Second thing, I'm going to check this 1U and 1V. 1U and 1V. Third, I'm going to check voltage between 2V and 1V. 2V and 1V. When you sum this value, it should be equal to this 2V 1V voltage. Here we are going to check R phase of your HV and Y phase of your LV voltage, and we have to check 1U and 1V, that is R phase of your HV and Y phase of your LV voltage. And when you sum these two voltage, it should be equal to Y phase of your HV and Y phase of your LV, that is 2V 1V. If this is satisfied, then condition 2 is okay. Now we move to condition 3. The condition 3, we have to check this 1W 2V. From here to here, we have to check. This should be lesser than this 1W 2W value. This value should be lesser, this should be greater. We have to check 1B 2V, that is HV side V phase voltage, LV side Y phase voltage. This value should be lesser than, when you go for measuring, HV side 1W 2W, that is HV side B phase and LV side B phase. This should be greater than previous value. If this all three condition is satisfied, then your vector group Dd6 is okay, it get pass. And we came to the end of this section. After watching this section, you may have the clear idea how to do vector group testing for this two vector group transformer. In part 3, we are going to see the star delta transformer for 1 o'clock and 11 o'clock. If you think this section is useful for your friend, then please share this section to your friends. Thank you for watching this video.